on Test 5, Section 9 on page 679. Let's do some problems. Problem number 1. Problem 1. If 6 cars out of 10 on assembly line are red, what is the probability that a car selected at random from the assembly line will be red? Well, 6 out of 10 are red, so if I take a random one, I have a 6 in 10 chance of getting a red car. If you look at the choices, there is no 6 over 10. But you can see that this can be reduced. If you divide the top and the bottom by 2, you get 3 over 5. So this is really just an exercise in reducing a fraction to its lowest common or simplified form. So the answer is B. Problem 2. Let me draw that diagram. So I have a triangle. Let's see. Try my best to draw this. There's an altitude that comes down to the center, splits it in two. And then what do they write? They write this angle right here is W. This is X, Y, Z over here. And they say, note figure not drawn to scale. AB is equal to BC. Oh, I didn't draw the letters in. So A, B, C, and then D. So they say that AB is equal to BC. So AB is equal to BC. So immediately a trigger should go off in your head. If two sides are equal, what does it say about kind of the base angles or their corresponding angles? That means that those are also going to be equal. So if those two sides are equal, then we also know that these two angles are equal. That should immediately be a trigger in your head, that we know that W is equal to Z. Okay, what's the next part of the information? And BD, this is BD, it bisects AC. So bisects means it essentially intersects it at its midpoint. So that also tells us that this distance here from A to D is the same as the distance from D to C. Which of the following cannot be concluded? That W is equal to X. That, let's see, W is equal to X. Actually, that immediately, I don't even know how I can conclude it. Let's look at the other choices. W is equal to Z. Well, W is equal to Z can definitely be concluded. That's choice B. So we know that choice B is W equal to Z. We know that this isn't it because we concluded that immediately. Choice C is that X is equal to Y. X is equal to Y. That actually can be concluded. Well, how do we know that? Well, since this bisects this line, we know that and that this is an isosceles triangle, even though that's not how I drew it, right? I drew this. This triangle is completely symmetric, right? Maybe I should draw it a little bit better. How do I know it's completely symmetric? Because this side is equal to this side, that is equal to that, and this side is equal to this side, right? And of course, this side is equal to that side. And actually, we can also conclude that this is a 90-degree angle. Because if this was anything other than a 90-degree angle, this wouldn't be able to bisect at the base. So, choice C, we actually can deduce that X is equal to Y. So that's not the answer. Choice D is AD is equal to DC. Well, they essentially told us that when they said BD bisects AC, so that's not our answer. Choice E, BD is perpendicular to AC, and I just said the triangle is completely symmetric. And given that it's an isosceles triangle, the only way that BD can bisect this bottom line is if it's perpendicular. So we can also rule out E. So our answer really is A. And really there was no way that we could figure out. And a good way of thinking about that is actually we could make this point, we could make the length of this line, this length BD, arbitrarily high because they gave us no information. The triangle could look like this, it could look like that, or it could look like this based on the information they gave us. So these angles could change arbitrarily. So we really don't know what those angles are. Next problem. Problem 3. Switch colors. I'm about to sneeze. Excuse me. If 30% of M is 40, so 0.3 M, that's 30% of M, is equal to 40. What is 15% of M? What is of m. You could solve this, divide both sides by 0.3, etc., etc. But the important thing to recognize is that 15%, or 0.15, is half of 0.13, right? So if 15% is half of 0.3, or 30%, then 15% m is going to be half of whatever 30% m is. So it's going to be equal to 20. Another thing you could have done, if that's not completely obvious, take this top equation and multiply by 1/2. Then you'll get 0.15 m is equal to 20. And that's choice B. Problem 4. If n is any negative number, so n is less than 0, it's a negative number, which of the following must be positive? Must be positive. So I can already tell you that the only way you can take a negative number and make it positive is either if you square it or if you multiply it by another negative number. So let's see, or if you subtract it, actually, now that I look at the choices. So I could tell you, a, n over 2, that's definitely going to be a negative number. B is definitely going to be a negative number. You're multiplying by positive. C, you're just adding something to it, so it still could be negative, if that's like negative 10 or something, right? D, you're just subtracting from it, so you're just going to make it more negative. E, 2 minus n. 2 minus n. This will definitely result in a positive number. Why? Because let's say that you could express n as the product of a negative number. Let's say n is equal to minus p, where p is some positive number, right? You can represent any negative number like that. Then 2 minus n is the same thing as 2 minus p, which is the same thing as 2 plus p. And we said p is a positive number. So there we go. So choice number 4 is definitely E. And you could try it out number. Try it out with the number n equals negative 10, and I think it should work out. Next problem, problem number 5. The ratio 1.2 to 1 is equal to which of the following ratios? So they give us a bunch of choices. 1.2 to 1, so it's a little bit more than 1 to 1. So we could look at 1 to 2. Now that makes no sense because 1 is smaller than 2. 12 to 1. 12 is 12 times 1, not just 1.2 times 1, right? So you're just looking for a ratio where the first number is 1.2 times the second number. 5 to 6, that's choice C. That doesn't work because 5 is less than 6. Choice D, 6 to 5. I think we hit it. Because 6 is just a little bit more than 5. And actually, if you wanted to confirm that, why don't you divide the top and the bottom by 5? So 5 goes into 6. How many times? 5 goes into 6 one time. 5 denominator. How many times does 5 go into 10, really? It's 2. 5 goes into 6 1.2 times. So the answer is 6 to 5. Next problem. See if I have time to do this. Clear image, invert colors. The legend of a certain pictograph shows that this thing is equal to 5 million new homes. Approximately how many new homes are represented by the symbols? So they drew that 3.5 times. 1, 2, 3, and then they draw half a house. Right? That's half a house. So these three are going to be what? This is 3 times 5, which is equal to 15 million homes. Right? And then this is half a house. That's what I tried to draw what they drew in the diagram. So half a house is what? 2.5 million houses. It's just half of a house, half of the 5 million. So it's 15 million plus 2.5. It equals 17.5 million homes. And that is choice D. You might be tempted to say that this represents 500,000 homes. But remember, this represents half of one of these pictures. And one of these pictures represents 5 million homes. So this is 2.5 million. This is 2.5, not 0.5. See you in the next video.